Proof by induction by Genesis Conway. We will prove that the sum of 2n minus 1 equals n squared for some integer n greater than 1. But first, what is a proof by induction? It is when you prove a statement true for some number n by proving first the base case, where n equals 1, then assuming the inductive hypothesis, where n equals k, and lastly, prove the inductive step that n equals k plus 1 for some k greater than 1. A proof by induction is an ordinary proof, just with a couple of tricks. Let's begin by calling our sum P of n. To prove the base case, we simply replace n with 1 and solve. So, P of 1 is 2 times 1 minus 1 equals 1 squared. On the left, 2 times 1 is 2, minus 1 gives us 1. And on the right, 1 squared is 1. Therefore, base case is proven. Now, we're going to assume the inductive hypothesis, where n equals k. In this case, P of k is 1 plus 3 plus 5, and so on to the 2k minus 1 term, which gives us k squared. Let's keep this in mind for the following step. In the inductive step, we're going to suppose that P of k holds for some k greater than or equal to 1. We intend to establish that if we add the k plus 1 term to the left-hand side, then our sum will equal k plus 1 squared. By distributing the two, we get that 1 plus 3 plus 5 plus 2k minus 1 plus 2k plus 2 minus 1 would equal the k plus 1 squared term. If we continue to simplify, we reach what will be our goal, which is that the sum of 1 plus 3 plus 5 dot 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 plus 2k minus 1 plus 2k plus 1 equals k plus 1 squared. We will begin by proving the left-hand side of our goal in hopes to reach the right-hand side. And so we start with 1 plus 3 plus 5 plus dot 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 2k minus 1 plus 2k plus 1. Now, as we're starting with the left-hand side, perhaps you've noticed that this portion of it is the same as the left-hand side of the inductive hypothesis, which means we can replace it with the equivalent k squared. And we'll bring down our 2k plus 1. Now, we can factor this to be k plus 1 times k plus 1, or simply k plus 1 squared. And so we've reached our goal and proven our sum. Thanks for watching.